So let's talk about power series and how to find the endpoints of the interval of convergence. This is a middle piece to a fairly long problem-solving process, so this is just one little part. So we're going to say that you've just done the ratio test, and you've done all the work to evaluate the limit, and you get some L that depends on x. Right, we're taking n goes to infinity, which doesn't take care of our x there. We know on the ratio test that if it's less than 1, it converges. If it equals 1, it's inconclusive. And if it's greater than 1, then it diverges. So since we're looking for convergence, then we're clearly going to pick this case because we want convergence. And we're going to omit the greater than 1 case because we don't want where it diverges. And then this last part here is where we're going to have to test the endpoints. So we're going to find some interval, and because we don't know what happens when it equals 1, we've got to test that. So let's look at a couple of examples here. All right, so I do my ratio test, and I end up with something like absolute value of x minus 4. So I know from the ratio test that I want to set this less than 1 because I want convergence. Now I'm looking for this to be in the form of x minus a is less than r. A is going to be the center of our interval of convergence, and r is going to be our radius of convergence. So what we're saying here is what values of x can I choose such that this inequality holds, right? Such that this is true. So there's a couple ways I can go about this. Since I'm already matching the form here, I can say, well, the center of my interval is going to be x equals 4. And my radius here, right, that's going to be 1. So what does that mean? That means if I had 4, I need to go 1 to the right to 5 and 1 to the left to 3, or in other words, 4, 1 to the left, 1 to the right, and I'm going to have the interval 3 to 5. So that gave me less than 1. And the issue is, what if I had made it equal to 1, right? Can I make this closed brackets here? Well, I don't know because the ratio test is inconclusive at 1. And so that's why I go in and test the endpoints, x equals 3, x equals 5, test the endpoints and see if the series converges when you plug in 3 and 5. Let's do another one here. If I had ended up with 2x minus 2, right, so that depends on x, I'm going to say I want this less than 1 because I want where it converges, but I'm not in the form x minus a is less than r. So I'm going to do a little bit of work here. And now I'm in the right form. So first I look at the center. I'm going to have the center of my interval of convergence is going to be 1. And then I'm going to look at the radius. So my radius of convergence is going to be 1/2. What does that mean? That means if I have the center at 1, then I'll have to step to the right 1/2 and step to the left 1/2. That's my radius of convergence. So my interval is 1/2 to 3/2, but I need to test what happens when x equals 1/2 and what happens when x equals 3/2 to see if I can make either of these inclusive, include the endpoint. I could have gone about this another way. So I could have said I have 2x minus 2 is less than 1, and then just gone right along with my algebra. And here I would have ended up with the same interval. So I'd have to do a little bit of work to think about, well, what is the radius of convergence and what is the center? And I can either by inspection see what the midpoint of this interval is, or I could actually, calculate it. I could add the 2 points together and divide by 2. That tells me the center, right? The center, which is the midpoint. And then I can take, for example, 3/2 minus 1 gives me 1/2, so my radius of convergence is 1/2. This method, I could have used that above here too in the first example. So let's switch colors here and just do that real quick. So I could have rewritten this, solved. That gives me my potential interval of convergence, right, from 3 to 5, and then either by inspection said that the center is 4 and the radius of convergence is 1, or I could have calculated that 4, that's my center, and then taken 5 minus 4 to get 1, that's my radius. So the whole idea here is that I am picking the values of x that makes this inequality true. Why did I do less than 1? Because I know that I have convergence when it's less than 1. So then I can get the, I know that everything inside that interval converges, and then I have to go back and test what about on the endpoints, because that's where it equals 1, does the series converge or not.